Hello.
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 Hello, everyone.
Oh,
Hey, everybody.
Okay. Hello, everyone, and welcome back to this week's tech session. Today, our host will be Partha and his company that will be presenting clean architecture. So I see Partha is tuned in. So Partha, you can take it away. Think you're muted. And I can't hear you. I don't know about the others, but I see you talking.
Because I was still muted.
Amazing, we can hear you now.
Okay, can you hear me?
Yes.
How about now? Can you hear me?
Yes, we can hear
Yes,
you.
we can.
Right. Okay. Today I'll be presenting the clean architecture general overall principles sample project, and I will do it with Theodora. All right. So let's get started. I will share the screen. Right. So okay. Now this one is essentially a lot of it. This theory is pretty well established in the circles outside Microsoft and probably nowadays even in Microsoft. This is coming primarily from Robert Martin, and this has been popularized by many people since him. Right, and the main thing here is how do we think about single domain applications? Right, let's do some housekeeping before we get started. So this is essentially the foundational skills of software engineering, just my opinion. Right, and this talk will focus on clean architecture. Right, the main idea about this is as your skill grows in all of these layers, your stress level comes down, your job becomes fun, and you get to focus on the business aspect and not necessarily wrangling the code or having a tough time pushing your code through. So therefore, mastering the skills is a worthwhile investment. The other thing is, all of these layers are independent of the day and age. So they're independent of framework, front end, back end, Angular, C Sharp, .NET, Java, Azure, AWS. Does not matter, right? If you know these, you can write it anywhere, right? And the same principles apply. Which means as these frameworks come and go, you can be in a position where you're independent and you can start coding, implementing anywhere, right? So far we've covered just 3. We'll take a jump here to clean architecture, and sometime later I'll resume the sessions down the line, right? This is a template for a single domain application, template for a multi-domain applications, and the principles, techniques, tools are in the domain-driven design. We'll cover that bit down the line. But in service graph and related areas, right, we're already starting to see domain-driven design take, starting to become, the concepts starting to become important. Things like ubiquitous language, things like bounded context. We'll cover that. Statutory warning, don't get me beaten up by your EMs. Some of the techniques of learning curve. So, if you are going to test out these things in your project for the first time, you may soon find yourself having spent a lot of time but not gotten anywhere, because these are skills that you have to spend a bit of time to learn. Definitely try them out on pet projects. My GitHub repo has a bunch of pet projects, and you can see what I've been doing last few years. And tying it on pet projects is an excellent way to build skills like hackathons and things like that. Happy to guide and collaborate you as necessary. However, if you before trying it on your project, make sure you have your EM approval, right? Engineering manager approval, explicit approval. Otherwise, don't get me beaten up, in short, right? All right. So, what do you guys think is the difference between, often you will see architecture diagrams represented in a layered wise and in concentric circle wise. So, anybody can tell what the difference might be?
I suppose the difference is dependencies. So in first way, like dependencies from the bottom. So the bottom layer has dependencies on high level components, right? High level
yes.
components has dependencies on low level components, and
correct.
The second one is like opposite.
The second one is also, you can look at it as high level and low level, but this is something that I heard like back in my college. This knowledge, wisdom might have changed over the years, but I remember my professor asked me, and none of us knew the answer. So what he had said was that in the first diagram, you could potentially bypass the middle layer and go straight to the third layer from the first layer. But in the second diagram, when something is represented this way, there is no way to access the internal layer without bypassing. So, but that's what I remember. I thought I'll share this tidbit. Maybe relevant, may not be relevant, but if somebody has a different understanding, certainly let me know. Right. For our talk today, we will be obviously covering the second one, because we will block out accesses into the bypassing this thing, because there is a genuine business reason for that. All right. So what's the agenda, right? So what is architecture? Again, when I say what's architecture, this is based on my reading, my experience, my knowledge, my understanding. Of course, there are fairly accomplished people here, so certainly feel free to give your opinion. And these are excellent kind of discussions that we want to have in our org, right? We do want to build this architecture culture. Remember, this is just a very strong opinion, but this is not a strongly held as well. So I'm happy to change my opinions based on what I hear. And this thing is, what is so clean about clean architecture, right? Third is the basic pieces of any application architecture. Again, some of this will come across as very opinionated, but that is typical Robert Martin style, and that is typical my style. But I aspire to be just like Robert Martin, where opinions are strongly held, but opinions are strong but weakly held. And then we'll walk through, Theodora will walk us through a clean architecture project, sample template that anybody can just copy over and start using. And some real world tools, utilities to get the theory into the real world where you can start being productive right away, right? And finally, some key takeaways and some references, right? So cool. Let's get started. So feel free to stop me if you guys have any questions. So what is architecture, right? So often we throw around this word quite a bit. It is essentially the intent of the application builder, right? So that's how it could be defined. Now, what it is that what it means is that it's what we are trying to build. Like what is it that we're trying to build, right? Independent of the details around delivery mechanisms or down the implementation details or the specific algorithms used, right? So it's a story that you can tell. So typical software story is input, processing, output, right? That's all software. But you can essentially fill that story and you can explain that to somebody, to a non-technical user, namely your customer. So you can explain your architecture to a customer without losing him. Now, in my opinion, what is a good test for how good is your architecture? Like, which means, can you easily explain it to a software engineer from 1960s, right? Who has no idea about today's stack, but who is an excellent software engineer, like say somebody like the inventor of Smalltalk, right? Or inventor of, say, one of the original guys, right? Who don't know what Azure is today. Can you explain them too easily without losing them, right? So which means that you are able to talk through design, right? My favorite analogy is like, can you explain it to a 10-year-old attentive kid? So can you put the block diagrams in place for him? Right, why 10 years? Because by the time the prefrontal cortex is fairly fully formed, so 10-year-olds can think in terms of reason, right? But obviously they don't have the vocabulary and the knowledge to keep up with you if you throw, specific Azure or algorithm terms. And if you can do these things easily, in my opinion, you are able to explain your architecture fairly well, right? What is not architecture? Again, is just my opinion. Feel free to contradict. MVC, CQRS, event sourcing, these are not architecture. These are design patterns for specific use cases. Like in some cases, some applications, a typical bank, ledger algorithm lends itself very well to event sourcing. So you try to use any other pattern there, you will get into trouble. Event sourcing is tailor-made for that, right? CQRS has a bunch of utilities. Again, CQRS, if you abuse, you'll get into trouble. MVC, if you abuse, get into trouble. But these are patterns. These are not really architecture, right? Again, whether your application is doing CPU versus GPU, it's not really architecture. It's execution optimization. Web versus console versus WPF versus a client app like JavaScript or one of your Electron clients. These are delivery mechanisms, right? Database is just a data store, right? It's nothing to do with your architecture, right? Cosmos versus AD, or SQL versus whether you're hosting the SQL in your VM. And then whether Azure Functions or web jobs, right? These are again job runners, right? The main things are, these are all details for specific optimizations, right? These are not necessarily what your application architecture is, right? Now, the main thing is that the intent that you have for the application, which is the architecture of your application, should be for the most part independent of any of your technical choices. So the whole idea is that you figure out what you want and then you go to the platform to see whether it gives you that or not. Right. However, there's a caveat here. Right. In each case, intent should be easily implementable and discernible, understandable just as easily. Right. But there's a reality check here. Often, what happens is, right, the code will differ whether you're writing CPU versus GPU. There'll be a slight bit of code that has to be GPU rated, right, in terms of CUDA and things like that. Or SQL Azure has DTU consideration, SQL on VM has maintenance, etc. You have to take care of all of that. So actual choice of platform does apply a back pressure on your architecture, but that ideally should be, for this another example, right? Again, easier is a judgment, but it applies a back pressure and it's a bit of leaky, but the whole idea is to minimize that leakiness, right? So essentially, good architecture is, it ensures that hard to change decisions are made upfront. So if you're going to design a video game, you're probably better off doing the rendering in GPU, right? So that's essentially a hard to change decision. And it lets you delay all other decisions to as late as possible. So, you're not only those few 2-3 hard to change decisions you're making upfront, everything else, delay, right? Why do you want to delay? Because it gives your business more opportunities to suit where they want to redirect your application to, what market they want to go, or what scenarios they want to run under, right? If you decide to run your entire application in GPU, right, that means you are restricting it to just the NVIDIA CUDA, right? And that means if you have a need to run your application on, I don't know, PowerPC, you'll have a harder time porting it there. What is so clean about clean? So feel free to stop me if you guys have questions. So what is so clean about clean architecture, right? So why does Bob Martin call it clean architecture? What I figured is it just his trademark. He likes to call clean code, clean coder, clean architecture, clean designer. He has everything clean, right? It's his consultancy trademark, right? That's what I figured. There's nothing inherently clean about it, right? It's just another, albeit battle tested. So it's been battle tested pretty much. Personally, battle tested it many times, right? It's a battle tested way to think about architecture for single domain applications, right? So that's where essentially, in my opinion, the cleanness of clean architecture is, right? But there could be 100 other ways. Even Bob Martin in his books says that his books are just one way to think about the software, and there could be many other ways to think about software as well, equally valid, right? So he repeats that himself in a number of books, right? He'll be the first one to tell you that he's highly opinionated. So what are the pieces of any application architecture, right? Right. So this is an excellent talk. Majority of this section is stolen from here. I highly recommend this. But if you don't want to, you can just stick through the next few slides. So essentially just this, right? Typically any end-to-end full stack or end-to-end client application will look like this, right? There's of course the user, and there are some top level pieces, right? And pretty much everything else you can classify into one of this, either the black or the purple or the green, pink or the blue, right? So we'll go through this one by one. So keep the context on the lower right. So use case, right? So use case is not covered here. So use case is essentially the purpose of your application, right? It is what the user sees, how the user interacts with your app, right? So for a typical order taking app, it will be like create order or update customer info, that kind of stuff. It is the value generated by your application. It is what you are getting money for or you're getting paid for. And it is also the target of acceptance tests. So acceptance tests are essentially testing use cases. For example, now the interactor, right? The pink ones, the pink one on the diagram, right? These are application specific business rules, right? What does it mean? It is specific to the application. It is in there for the purposes of the application, like creating the order or updating the customer, right? It is not provided by the framework. So .NET framework or ASP.NET Core is not going to provide that for you because it is very specific to what your user needs, what your business rules you're going to apply, right? Example, create order, update customer, or in service graph, it's going to be, update data flow or get Azure locations, that kind of stuff. The next thing is the entities/business objects. That is the far right blue things. These are application independent business rules, right? These are just specified normally as POCOs, like plain old C# objects. This is specific to the domain, right? For example, for the customer order taking app, it will probably be a customer will be an entity, order will be an entity, right? This is independent whether your application is the order taking application or whether your application is a customer relationship management application or another application is something else in that domain, right? But in that domain, the entities are given, which is customers, orders. Similarly for service graph, right? There are only about 8 or 9 entities like services, resources, locations, boundaries, right? And that's a frozen list. So no matter whether you're applying service graph, whatever the application like experience symmetry or EUDB or FedRAMP or anything else that comes in the future, you will just be dealing with those nine entities, right? That's the business object, right? It is independent of and not provided by the application domain, right? So one of the application domain for create order for the customer order application is going to be the order management application. So there it's you're not, so that domain or that application is not going to provide the order object. The order object is going to be provided by the central domain itself, right? It is independent of any storage mechanism, SQL, Cosmos, sorry, typo there, Cosmos, whatever you want, right? It could be a text file, doesn't matter, right? Right, and similar for service graph, independent of whether it's UDB, experience symmetry, FedRAMP, right? A service is a service, right? So every application has the core entity as a service. right? Again, I haven't given, not to make it very generic. Now, the boundaries are essentially the green layer on the bottom right picture. So this is what helps you get data in and out of the interactors. Interactors are sort of the implementation of application business rules, right? Application rules, sorry, so the business rules. Now, typically for ASP.NET applications, these are the controllers, but for a simple .NET class, it could be also an interface, right? So typically it's their protocols. It's basically how you interact with the interactors, right? Interactors are fairly abstract, but this is where, you can call, you can return. Delivery mechanism is what packages this entire thing and makes it usable for the user, right? So it could be a Electron app like Teams or the same Teams application on the web, right? Those are two different delivery mechanisms, right? User talks and interacts with the applications through this, right? Then examples of delivery mechanisms are web services, console, client apps, whatever. The main thing is that this one has no impact on any of the others. So boundary is independent, mostly independent. The interactors are mostly independent, are fully independent. Entities are definitely independent of the delivery mechanism, which also means that it's Teams is a classic example, right? So the same team client app on at least as far as I know, for the most part, we have a Teams expert here and he can tell. For the most part, is the same code base that is having the web UI as well as your Teams web client, the desktop client, right? So that's an example of where you're just reusing the boundary, interactors as well as the entities in a different packaging mechanism, right? So that's the beauty of it. Now, which is what it is. So it should work independent of the delivery mechanisms, which means now you can start writing tests for it because it has no coupling with ADO.NET or ASP.NET or WPF or any of those. Now, obviously, users are somebody who's giving you the money, so is the most important guy probably, right? So, any questions so far?
Yeah, I have one, if I may.
Sure.
So, seeing this diagram, where would you put the persistence level? Because you said you are taking out the persistence from the entity, which I agree basically, but I would expect that there will be some place which will take care about the persistence, even though it doesn't matter whether it's SQL or no SQL, for example.
Correct. So yeah, I'll give a short answer now and then we'll cover that. So short answer is, in my opinion, it's the entity will be, so entity is an abstract thing. Entity is like a bunch of classes, but what makes it real, where you store it and where you rehydrate and dehydrate it and freeze it and thaw it, right? So that's where the persistence comes into effect, right? So anything that packaging mechanism uses to reload this into memory, work with it and save it back, that's where the persistence comes. So I would say that the persistence mechanism is injected into this entire thing somewhere through the delivery mechanism. So the delivery mechanism, the wrapper ensures that you are given where you are going to persist it, right? The answer might be a bit handy, so just give me a minute and I'll cover that shortly. Right?
Okay.
There's a real example for that, right? Now the other thing here is the request and response model, right? Which is, if you see on the left hand side, this is how the customer essentially places a request. Now the request has nothing to do with delivery mechanism. It's just a collection of, you can think of it as a URL parameters. So the customer just says some, I want ID is this, type is this, and so on and so forth, right? That's the request model. Delivery mechanism packages into an object, sends it through the interactor. It's not, the main thing is it's not HTTP request and HTTP response, right? And then finally the interactor interacts and applies the business logic, transforms that request into a result, sends it back into the user, right? So in essence, the delivery mechanism was the packaging and repackaging and sending it back, right? So now I think that ends this section. Now the beauty here is, right, just note that the dependency arrows. So there is no incoming dependency to delivery mechanism. Delivery mechanism is independent. The boundary interactors and entities are independent of the delivery mechanism, right? Which means that you can package this anywhere and run it anywhere in the ideal scenario, right? There are real world considerations. But again, the trick is to make sure that how repackageable your application is, right? Now, if you're going to keep the delivery mechanism independent, right, it also lends itself nicely to writing, packaging it differently. So if your PM comes and says, hey, I want a client app, Teams is not going to work just as a web app, but also I want a client app, right? Hey, look, you can redeliver it in that mechanism, right? And it also means that you can start writing tests now, because the rest of the code is independent of this. So you can actually write full-fledged unit. You don't have to write UI tests, that checks HTML IDs and things like that. Fragile tests, right? You can write proper tests that are, that will fail only if there's a problem, right? And also notice the dependencies, right? So entities never depend on interactors, and boundaries and interactors have slight, it depends on how you define it. But the main thing is that entities are separate from interactors, right? Interactors, again, business. So entities do not know how they're getting used. That's the main thing, right? So entities, for example, right, the service graph service entity, or the resource entity, or the location, or product or feature entity could be used in any of the applications like FedRAM, Experience Symmetry, or UDB boundary, right? U data boundary problem, right? But the point is that service itself doesn't know where it's getting used. It could be in any of the 3 applications, or 4 applications, 5 applications down the line, right? So that's the key. So the main thing here is that I think that's what makes it, in my opinion, clean, right? The architecture is clean because you're clearly delineating the direction of dependencies, which means anytime there is a clear dependency like this, which means you can change the host without necessarily worrying about what the internals are thinking, right? Which means you're decoupling and cohesive, and that's the holy grail of software, right? So Theodora, you can take over, and I think Jakub should get his answer here.
Yep. Okay. So next we can do a walkthrough of a clean architecture project. So here you can see that we have separated things into the entities layer, which is the entities business logic. Here we have the domain, which contains our entities. We have the application business rules. So over here, and they are the application infrastructure, the integration tests, the use cases, which Pata mentioned are the purpose of our application, and then unit tests for those use cases. Sorry. So then we have the interface adapters, which are the delivery mechanism. So here we have the API and acceptance tests, and then we have this common, which is just general utilities that are used by our application. I can share you the sample use case just so you guys have a general idea. So the use cases are defined in the application business rules, and they're the intent. So we have divided them into queries and commands, and I can show you a query that is used to get the service data flows. Here we have the query, which has all, which in return returns a service data flow view model. We can pass in the service name, the organization name, and the division name, and then in the same file, we have the handler, which is which makes it easy for the developer to kind of find the definition of the query and the handling of the query, because they're in the same file, and it gives the developer kind of guidance to do the right thing from the beginning. And then basically this simple query just fetches the service data flow, data from Kusta. But as we know, those things should go into the infrastructure, so the connection to Kusto and the mapping of the responses to the C# objects. So in order to not violate the dependency rule that we mentioned, the use cases just defined a common data access interface, and then the infrastructure layer basically is the one that takes care of all of like the implementation details, so the Kusto specific things, so that we don't have this sort of so that we make sure that the dependencies between the layers are not violated. because infrastructure should not depend on the use. Infrastructure should depend on the use cases, but the use cases shouldn't know anything about the infrastructure at all. So next I can go back to the presentation. Sorry, kind of.
Yeah, use the bottom bar. Use the bottom bar to browse to where you want, then you can click on that.
Okay. So let's go over the tools and utilities that we've been using. So we've used KQRS, which stands for Command and Query Responsibility Segregation. And that's a pattern that is used to separate the reads and the updates operations from the data stores. It helps us to achieve to maximize performance and scalability. But how does it help us to achieve that? Well, for the reads or the queries that I've shown, the application returns various DTOs. But for the writes or like the updates or deletes, so the commands in our use cases, that model may implement some sort of complex validation and business logic. So our idea here is to separate create a separation between those queries and commands to resolve the issues and kind of simplify the implementation. The next thing that we have is Mediator, and that is a .NET library that is used to implement KQRS. It helps us in the decoupling of the process. It helps us in separation of the process of sending the messages from handling the messages. So I can show you in the code. Basically, if we go to the interface adapters, here we have the controllers and the data, for example, let's take, for example, this data flow groups controller. As we can see, it's just one line, and we use Mediator to send out the query. Therefore, the sending of the message and the handling of the message itself is separated. So the handler in sending of the query or it could be the command is separated.
Just wanted to add a comment. You might have seen from the code base that the authorization attribute is disabled. Yeah, we don't. Yeah, we are essentially a privacy tool that may appear that we don't believe in security, but that's not the case. That authorization is something that we're working on this sprint, and we'll turn it on in about a week or so. So this is just a temporary mechanism, and this is not getting deployed yet.
Sure. Let's continue. So yeah, as we noticed, there's only a one-line REST API implementation, and then the query and the query handler are in the same file. This this allows us to avoid breaking changes. So as we add new use cases, we just add new endpoints and queries. And in turn, it's very easy to change the functionality of an existing use case if we need to. And just to mention again, so this enables the developer to do the right thing from the beginning. So they're really very good match together. Other tools that we've used is Fluent Validation. That's a .NET library for building strongly typed validation rules, and it allows us to easily define those rules for our queries and commands. I can do a code walkthrough, but let's just go through AutoMapper so I can do both of them at the same time. So AutoMapper is just a pretty self-explanatory name. So it's a .NET library for transforming objects from one type to another. And it easily allows us to map between entities of the domain and then requests that we get from and the responses that we send to the user. So let me just show you. So for example, if we want to, we have this query to get the service data flows. As we can see, we can pass in a service name, an organization name, and a division name. If we want to create like validation rules for this, it's very easy to do. We just defined a get service data flow validator, and then we can write rules for the specific rules. They're very easy to do. This one is very simple, and it just says that organization name, division name, and service name cannot be empty. And then I would just like to show the auto mapper. So for example, we send back from the APIs a view model of this. So we have the service data flow, which is an entity, and then we can create a service data flow view model that maps out from that entity. And if we need to, we can define the way the mapping is done from one object to another. So here we just have that in the view model, we have state, order, and name, but the entity actually those map out from the data flow state, the data flow order, and the data flow name in the entity. So let's go back to the slide.
Vlad has a question, I believe.
Oh, go ahead, Bud.
Yeah, I had it. I will maybe ask later, but maybe now. If you have defined query and query handler in one file, why didn't we add validator to the same file to keep everything together if you decide to keep everything together?
That's a good question, but I think handling and validation should be separate. At least that's what my opinion is on this.
So it's not, yeah. If you decide together, let's together.
Yeah, we can change it. Depends on the consensus. This is just the starting point, but yeah, that's a valid. I mean, one way is no better than the other. But depending on what the consensus is, we are happy to change it. So feel free to suggest it.
Okay. Someone else had a question? Yep.
Dimitri.
Go ahead.
You're on mute.
Sorry, yeah. You are mentioning that CQRS will give us the performance advantage. Could you explain how?
Yeah, so the way it happens, right, for queries, which is reads, typically what you can do is you can have some caching layer built in for you, but often for writes, right, you would want them to be write-throughs, right? So when you are separating out the reads and writes like this, for the reads layer, your implementation can go through a cache that is updated reasonably frequently, and the write can just directly pass through. So that's the performance possible performance. There are many other things we can do, but that's an example of a performance optimization.
Mm-hmm. And one more note regarding those many classes in one file. From my experience is counterproductive because Visual Studio has the search files, plugins, and with the tools like ReSharper. And if actually name of the file doesn't correspond to the name of the class, it's very hard to find it. So yeah. I think it's better to separate them out.
Yeah, that's my recommendation as well, right? Yeah, but yeah.
That's it. Thank you.
Okay, I guess we can proceed. So we also have Swagger integrated. So during the build, Reflection is used over the API controllers to auto-generate Swagger documentation, a TypeScript client, a C# client that will be used by acceptance tests. And this enables us to have clients that stay in sync, so the builds break rather than us having runtime inconsistencies. I can show you.
So while she is sharing, right, so typically one often problem is that since refactoring is heavily encouraged in this code base, so anyone can just go and do a controller and just change the name of a type or a view model, right? And that might end up having an effect on the REST API, which means that instead of having now a runtime problem where you go figure out that problem in the runtime, say potentially in production, now you can't even build, so your PR is not going to go through. So which means that as soon as the backend, so the last step of the backend build integrated is the MS build, so which Theodore will show, and that MS build essentially calls into Swagger to generate the TypeScript client, And then based on that, the next step is to do the front end build. So which means that if you're done a refactoring that is inconsistent with what the front end is expecting, your build will not succeed. So your PR is not even going to go in.
Okay. So I can start the application. Here you have the Swagger documentation that was mentioned.
Auto-generated, yeah. And you can do a lot of tricks in this, like you can have descriptions, you can have parameter descriptions, all of them can get reflected. We've done a fairly quick work here, but depending on how popular the use is and depending on whether the PMs want us to have this published as a proper, eventually I think they will, but in this case we can add nice descriptions and attribute based things. Plus we can group them into saying that, hey, this is this class of APIs, this is data flow management API, this is service management API. So, and all of this is auto generated. We've not written even one line of C# HTML code here, right? This is all generated by Swagger by reflecting on the controllers.
And I can also show you so we have the TypeScript file that is generated, and we also have the C# client that also gets generated with this step.
So the TypeScript gets auto-used by the front end. So front end is what calls into the REST API through the TypeScript, and this TypeScript essentially is a bunch of error checking. You can see, right? It handles each code. It makes sure that the headers pass properly, which you would normally have to write a lot of front end code to do, right? You could get it right most of the time, but sometimes subtle errors will creep in, right? So, but this is all template code that Swagger automatically generates. And then the C# file is what is used by your acceptance tests. So the acceptance tests are simply going to call each of these APIs and fire, call into the REST APIs, and then check the end-to-end scenarios. And this will happen in the CDP itself. So that's the whole purpose. The whole deal behind Swagger is that it is integrated with MS Build. So as soon as the backend build finishes, like it's the part of the build step. So if Swagger breaks, the build breaks. So, and Swagger auto generates these three things: Swagger documentation, C# client, and the TypeScript client.
Do you publish these clients to some repositories like Nugget repository or NPM?
Oh yeah, it's open to that. Certainly we can do that. And if, I'm pretty sure that there is. I saw one user story in our backlog where we want to publish it for certain partners. They'll want to use it, and that point of time, exactly what you're saying, right? You just publish it in NuGet and give it, or publish the TS client.
Great.
Okay, and additional tools and utilities. So XUnit for unit and acceptance tests, dependency injection using the .NET SDK, Entity Framework Core for database access and upgrades and seeding. So that was covered last time by Ivica. We also have .NET Analyzer style settings, editor configs that are integrated with the build so that coding style is uniform, but it can be changed based on team consensus as long as it remains consistent. Go ahead, Tomasz.
I've got a question related to front-end things, like do you use some build tools like Webpack, Hot Reload, or something like this? You are using React, so you have to use something.
Yeah, it's inbuilt. So we're not covering React here. React will be covered by one of us down the line. But yes, the React part of the application uses whatever React app provides.
Okay.
Including hot reload, including, I think the hot reload we have not configured it yet, but you're right, it's there, it's right there.
Okay, so the key takeaways.
All right, so I think we are pretty much at the end. So key takeaways, well, not many really. So essentially thinking about architecture, main thing is what's the intent, right? Like what is it that we're trying to do, right? And then platform becomes something that enables us to do that with certain back pressure, right? So the example I give is, right, so if you are a non-software company and if you're going to hire a bunch of software developers to do your work, You're not going to go ask the software developers, hey, what can you do for me? You will have an idea of what you want to do, and then you will hire a bunch of software developers and they'll do it for you. And often software developers will give you good suggestions that you might want to change your business. And that's the back pressure that sometimes your platform will apply on you, right? So main thing is to be able to understand the intent and at least initially not worry about DVs, frameworks, and things like that, right? Most important is to make sure that you spot the hard to change decisions and make them upfront, and all other decisions you can delay as late as possible, right? This is so that you give your program management team as much leeway as you possibly can for them to repurpose your code in the way they think is the best. I think there's a typo there, but then second thing is essentially when you are trying to think about the intent, right? It's a good idea to sort of break down the intent into what's the use case, what are the domain entities, what are the interactors, what are the business rules, what are the boundaries, what's the delivery mechanism, and how do you think about request and response? And then comes your platform, right? So then you go to the platform and figure out, okay, what is the best way to do it, right? For single domain applications, start with certainly the clean architecture sample. Feel free to copy it. I've been copying it over for, I think, for a long time now, right? Every project I go to, I copy the previous project and get together people, make improvements with that. That becomes my template for the next project, right? So I've been stealing for a while now, for a long time. Right, and certainly save time, become super productive with the tools and utilities presented. CQRS, Mediator, Fluent Validation Mapper. These are super hyper productivity tools, right? These are open source tools. We have a 1CS review coming up. We'll just disclose all of this that we are using it. So one ES review, right? So these are the main key takeaways. References, mainly these things. The first one is my crush. He is Robert Martin, and first one and second one is Jason. He's a friend of mine. He was a consultant with me. He's a popularizer of clean architecture down in Australia. So I had worked with him. First one is, you guys know Bob Martin. He's totally my crush. First one and second one are Theodore's crushes. So that's pretty much it. If you guys have any questions, we can geek out.
Thank you, Partha and Theodora.
I have a question. What is mediator pattern advantage? What it brings? What else things cannot achieve? Except if the code is in another class.
So this one doesn't talk about the mediator. I know that there's a separate. I know you're referring to the mediator pattern, but this one is talking about the library, just for the very specific purpose of decoupling your application from your controller. So we haven't used. I haven't put in the full mediator pattern here. It's just use the library just for the decoupling purposes.
Okay.
Okay, but yeah, mediator pattern, I'm not fully clear what it does. I mean, if you have a minute, maybe it'll be good to. But we can discuss later also if you want.
Okay, good. Thank you.
I have one comment. Maybe it's fair to mention when you are speaking about CQRS that that's when you start using CQRS, it brings eventual consistency. So you have to be aware of the fact that, like, when you get the command, like the read side doesn't have to be consistent immediately.
Yes.
It may take some time. So it's like eventual consistent.
Correct.
So it's good to be aware of that. It might be the limitation. On the other hand, it gives you really freedom when you, for example, work with some kind of logs, and you want to avoid having logs on the database where you have to do a lot of reads and a lot of updates. Then this is very good pattern to use.
Yeah, absolutely, and that's also the performance optimization, right? Like you don't have to go to the database. You could just go to return of a cache for some of your reads depending on your scenario, right? But totally agree with you. It brings in eventual consistency, so it needs to be thought through.
Yep, thank you.
Okay, so thank you very much, Parta and Teodoro. I see that no one else has any questions, so I think I can put an end to today's presentation. If anyone is interested in doing a tech session for the next weeks, please use the feedback form. And if you want to share your impression on how our presenters did today, again, you can definitely use the feedback form to do that. I am excited to see you in the next tech session. And that will be a bye from me.
Yeah, I have one more thing, if I may. Sorry
Yeah.
to interrupt you. So if there is anybody next week, I would like to present how to work with AAD, like Azure Active Directory, from the perspective of developer. So if there is anyone who have experience with working with AAD and want to join me, we can do it together. Anyone is more than welcome to help me with that.
That will be a hot topic. Looking forward to it.
Great. Thank you, guys. Nice job. See you.
Thanks, guys. Bye-bye.
Thanks, guys. Bye-bye.
Thank you very much.
Bye, guys.
Bye-bye.
Thank you.
Thank you,
Bye.
guys. Bye-bye.
Thank you. Bye-bye.